So I'm going to talk to you about what is the SOCIB, but I don't want to do a typical presentation marketing saying all what we are doing. I want to start directly by application we are developing using CMM's data, because I think we are all here to hear about experiences of end users about this data. So you can see on this map where we are now, and I wanted to know also where are the Balearic Islands, on the island there, Mallorca, which is one on the 4 islands in the Balearic Islands. So SOCIB is mainly an observing and forecasting system for the Balearic Sea, and you will learn a little bit more about us later. So as I said, I wanted to start directly by an application, not too much introduction. So in April this year, we had this program. So what happens is that a ferry between Peninsula and the Balearic Island had a problem. It was burning, and directly we had a call from colleagues saying we should do something. I mean, we have the data, we have the tool, what can we do? So we were afraid that oil spill could happen. And we thought, okay, what can we do? We need to do something. So what was the response of the SOCIB? So the first idea was, okay, we have a research vessel, we have ship, we have buoys, drifters, etc. We should go there, but is it what we really have to do? No. The answer is no, we cannot do that, simply because it's not in our responsibility. We're an observing system, and going to oil spill, etc., it's not in our task. So what did we do? We think, okay, we have lots of information, and decision makers have to do the best based on the information we have. So we decided to put all the information we have together in a way that user can, decision makers can take the best decision based on scientific and realistic data we have. So we developed what we called a Seaboard. It's mainly a visualization dashboard. When we put all the relevant data, so we put forecast of wind, forecast of waves, the ship positions, a lot of information that only one screen, the decision maker can understand the situation based on scientific evidence. You can see, for example, here, it's oil spill forecast from our model. So it's important to see the probability of if there is an oil spill. We're not sure it could have. It's a possibility we have to consider. If there is an oil spill, where is the oil going, and in which area of the island it will reach. So that's the tool we developed just in case something happened. We think it's the best thing we can do given our task. So what was the Seaboard? It's a real-time information panel to help user. How, as I said, is to gather all the relevant information that we could find. So it means local data, local model, CMM's products, in situ data. We'll give more details. It contains this forecast for wind, currents, and waves, which are very important in case of search and rescue or just oil spill control. In situ observation close to the ship. We were lucky that we had mooring close to the position, last known position of the ship before the fire started. The output of the oil spill model, also very important, and the last ship position based on AIS, the automatic position system. So the potential users were 3. First were the Maritime Security and Rescue Society, which is called SACEMAR in Spain. And they are the responsible for all the actions at sea. So it means we cannot go at sea with our ship. They are the responsible. So if they ask us to do something, we will. But we cannot do anything without their approval. The second was the regional Balearic government. In case an oil spill happened, it means that they need to control what's happening close to the coastline. So if they need to protect some area or not. And the third potential user, of course, it's the public. The public want to know what's happening. They want to have good information and not only a picture of a ship burning. They want to know what we can do for them. So the Copernicus Marine Service added value to clearly cite the data we use. So we use the Mediterranean in situ data. We have a mooring close to the island, which gave us giving us the sea level, the wave characteristic, and the wind at sea. We use the Mediterranean Sea physics analysis and forecast because our own model is it's a downscaling this Mediterranean model. And also use satellite altimetry, the gridded product, to get the mean geostrophic currents, which were also useful. So all that, all in all, provide an overview of the situation based on the scientific evidence. So how do we get there? How are we able to show all this data at the same time? So as I said, SOCIB is a multi-platform observing system. I wanted to say that not so long ago, I don't know how many years, but it was like this, oceanography. It means the only instrument was the ship and the human, with some more, of course, more elaborated instrument that this guy with the head inside, but it can be a nice way to measure properties. Now it changed, and we have to understand that the landscape to measure water properties is very different. You have, of course, the ship. We will probably always have ships measurement with human inside measuring the water properties, and also in the laboratories. But we have a lot of satellites as well. We have the gliders inside the water giving nice high-resolution data. We have the moorings. Now we have turtles in the Balearic Sea. So we have plenty of instruments. And it comes from a new requirement in oceanography. It means to be, for in-situ data, we need to be at many places at the same time. So, and also for the data availability, we want all the data to be free and open access. I think it goes in line with what is done now in Copernicus Marine Service, that you can get all the data without any problem. You register once, and then you get all the data. You can use them. Whatever, if you are a company, a student, general public, you can use all the data. It's very important. So this multi-platform observing system that we have is very necessary to understand well how the ocean behaves. Of course, with model, you can reproduce something and explain and do forecast, but without data, it's impossible to get as close to true as possible. So thanks to lots of technological developments, like the gliders, I will give a few more words about glider later. Thanks to these developments, we are able to really well understand what's happening in the ocean. So for us, it was also important to provide the data to the general public, not only to scientists. And now, the first thing I do now in the office, it seems a game or a toy, but I like to tweet data. I have a Twitter account for the SOCIB data. And when I see interesting data, I tweet some image, etc. I think it's a way to interact with the public because they can see how it's a very huge increase in the temperature of the sea, and how very high waves are forecast. So it's a way that public see that we can provide real data, and they can be interested in oceanography in general, because it's not so easy to have people interested by this. But we don't do, of course, I cannot spend my life on Twitter tweeting data. It's not the only way we do so. We have developed a visualization dashboard, so things that are in some hotels in the Balearic Island. And these hotels, they have a screen, like this screen maybe smaller, when we put information of interest for the user of the hotel. So they want to see how the beach has evolved over the last months or weeks, the air temperature, the weather forecast, the wave forecast that we can see here. So it's always nice for them to see kind of a mix between forecast and real data, and see the condition in real time. So it's a way we have collaboration with this hotel, and I think it's a nice private public interaction. Also, we developed a smartphone application, and again, the goal is to reach the public, the general public, not only scientists. So the first goal we had with this app was to get all the data at SOCIB through this application. So we have not only model forecast for waves and currents, but in-situ data, like the fixed station, can be sea level, weather, can get the gliders, the drifters, some image from the camera. I will show you. And if you want to download, it's easy on Google Play, on App Store. You just look for SOCIB and we'll find it. So here you can see the numerical model output on the left. It's a hydrodynamic model, ROMS, and on the right, the animation shows the wave height. I think it's 27, 28 of November, so last week, when you had quite high waves in Balearic Island. So this numerical model allows us to get really high resolution products that we want to share with the public, and they don't have to download the data. They can just turn on their smartphone and see the data. We have also HF radar to measure the currents. I think it's a product maybe that is not so much known up to now. It gives very high resolution currents in some specific area. So it's, the next talk is about HF radar, so you will hear more details about that. So it's kind of data we also want to share with the users. We can see where the research vessel we have is located during the cruise. So we had the cruise starting 26th of November, and we see the position here, the track it has done to measure the characteristic of the northern currents in the Balearic Sea. Also, we wanted to show the fixed station. It's very important because we have some weather station and some station measuring the waves, and there are very important parameters that users are happy with. The drifters, it's the same. The gliders position, we think it's also important. And for some of the hotels in the Balearic Island, we have installed some cameras, and these cameras give real-time images. It can be good for tourists, for surfers, but also for scientists, because with time series of images like this, if you have many images at the same place at different time, you can compute some nice statistics and know where you have the return currents, which are very dangerous currents that take you, if you are swimming, you can be taken and go offshore. So with this, we can really diagnose the location of the return current. So it's a good way to do science and to explain people, to inform them that the sea is dangerous and how they have to behave if they are caught in this kind of currents. So all these images are available on SOCIB webpage and also on the smartphone application. So what is behind the application? I think doing now an application, it's like a fashion, everybody's doing application, but we need to do something that we don't depend too much on private companies. So in that case, let's imagine we have a new station, new mooring in the middle of the Balearic Sea. I don't want to have to program again the application. It takes too much time. Nobody has time to do that. I don't want to pay a private company to change our application and to say, okay, we have a new station there, please implement it in the application. No, that's not the way we decided to work. So what is beyond, I think it's what I will call the clever part of the application. It's the system which is called data discovery. So basically, we have our database, and on top of that, we build some services. That means any user can be, any developers can connect to this application and say, I want all the data from this station during this time. And directly, you will get, for example, all the weather station data in just following one of the services indicated in this link. So it means that if we install a new station, directly it will be included in the response of the service. So I think it's a clever way that the guys have programmed the app, and we are not so dependent on developers. We are dependent on our own services. So this service provides a list of the station in deployments, extract the measurement of the platform. So it means the developers don't need to know exactly how the temperature is called in the file, in which file it is located. All that is taken into account into the services. Obtain time series from the data and generate some images like the HF radar output that we've seen, or maybe the numerical model output. I said I wanted to talk a little bit about gliders. I think it's an important tool in terms of innovation and interaction with companies. So gliders, they are quite recent in terms of measurement of oceanography, and they combine the three pillars defined in Horizon 2020. So the first one is the industrial leadership. The second one is the excellence in science, and this combined with the societal challenges. So these three pillars are well applied with the gliders, and it's a reason why in a few years, let's say a little bit more to 1 decade, the glider have started from only a paper and now a reality. It means every day we have lots of gliders all around the world giving lots of data. So maybe this figure explains how the The paper, so in blue, so we start in the 90s with the Slocum papers, has evolved through different steps with in light blue experimentation. And you have this color here, commercialization. So it means we have interaction between scientists, private companies, and also at the other end, we have the public. So we can do very good science using gliders. In this case, I show a high resolution survey we had last year in May in the Balearic Sea, and we can really get high frequency variability, high resolution variability thanks to the glider. And sometimes the model, we always think, okay, the model are able to reproduce everything, but when we compare to glider, we see it's not the case at all. So the glider really capture a small scale variability. And that's why we think it's something that needs to be used a lot for comparison with model to see if the model behave well or not. This I will switch. It's basically explaining that we can derive lots of useful information with the gliders. So last pillars was the interaction with the society. We developed a web page application which is called Follow the Gliders. So you can check with your smartphone if you want, because the web page works so well with the smartphone. And the idea was to show the glider data in a way that anybody can understand what we are doing, because it's complicated, but we can put it in a simple way. So if you start here, you'll see Follow the Glider homepage. We have for students, teachers, and explore, meaning you can get the latest data. So if we click here on export, you will see the latest position of the glider. And if you click on the map, you can get interesting information like the distance it has traveled, the battery state, the measurement it has done. So I think it's presented in a nice way for students. We can get the real profile in real time measure for the gliders. And also, we like to share our experience with students, sometimes visiting SOCIB and showing them what is a glider inside, how it works, because it needs to be close to society so they understand that what is in, how these things that measure so many things and spending so many days at sea, what does it look like in reality. So a few numbers about the glider mission this year. So I had 8 missions, more than 200 days in water. And so an interesting figures, maybe it's not the exact price, but more or less it's that. Any profile measured by a glider, if you take into account the cost, maintenance, etc., it's about 30 euros. And if you compare with the measurement done with the ships, it's very cheap. I mean, 30 euros per profile. So we can get a huge amount, a massive amount of information thanks to this nice profiler. So these are the map of our deployments in 2015. So basically, we try to be in this area between the Spanish Peninsula and Ibiza, where it's a very interesting region in terms of oceanography. So in Spain, most of the time, we try to have gliders there, but you can also see these strange tracks here. It was a mission to sample small eddies that we've seen through satellite data and wanted to see what's inside the eddy, because satellite, okay, you only see the surface, but what's behind the surface you need to be in situ to understand. So wanted now, the current development at SOCIB is to help private companies or any developers to get our data. They are freely available right from the beginning, but now we want to improve this data access. So what we are developing is the API, application programming interface, with again some services that help people to get data without having to lot of programming or downloading on the data. You can get you don't have to download the file. You can get the data directly for your application. Basically, the steps to get the data in different formats. So NetCDF. It's a quite famous format now in this science. JSON format as well. We have built a data catalog for user to find the data easily. And the main objective here is to facilitate the development of any application using the data, because we provide the data and we hope that small companies can build something on top of our data. I think it's the way it should work. Data are acquired once, but they are used many times. That's a sentence that we have here several times. So it's how the catalog looks like. So it's a usual catalog. You put region you want, the platform type, the period, and you get easy access to the file. So the conclusion of this and the main message. So we've seen that in the recent years it's necessary to be multi-platform. So not only ships. We will see that tomorrow during the in-situ training. We need to have many platforms to well understand what's happening in the ocean. And we will contribute to models through assimilation of data or validation because we have many types of data. It's very necessary to have open and free access to data, but not only open and free on paper, because sometimes you read, yeah, it's easy available, it's open, and at the end of the day, you cannot download the data. No, the data need to be available easily for everybody, not only scientists. And creating jobs for data, we think the way to follow is to build tools and services, ways for any user to be able to have a very, very easy access to the data without having to do a PhD in oceanography or vocabulary to know that sea surface temperature or it's named in the file, etc. We need to simplify things that everybody is able to get your data. So that's all. Thanks.